So in the CHTC, it seems like every week we have some really hard technical question, and every time we ask, well, who's the expert about how glidein startup works? It's Mats. Or who knows how the OS pool container works? It's Mats. So Mats Ringe seems like an awful lot of hats, each of which he's an expert in. So for our next speaker, it's Mats.
All right. Thank you. Yeah, so I am going to talk about something. We talk about communities here, right, for several days, and I'm going to talk about a little of the work we have done in the communities of the ACCESS and the NAIRR Pilot. And this being High Throughput Computing Week, we are focusing a little bit on services and capabilities, deployments. And the talk is basically two parts. We're going to talk about some of the AP work, access point work we have done. And there's a couple of those. And then we're going to talk about how we actually get jobs onto these resources. And that's the execution point part of the talk. So Pegasus is workflow compiler or workflow planner that takes a higher level workflow description and it plans it down to HTCondor DAG. And then Condor is running that workflow for us. And the reason I mention this, right, is that when users come to us and they ask, how do I get Pegasus installed? Where can I run Pegasus well? Most of the time that becomes a discussion about, where is a great access point? How do I deploy a Condor access point? So that's why this is a really important part of the work we're doing is to get those access points working and being accessible to the users. Now, the other thing that you have to understand is how we got to this point in interacting with these communities. And I mean, we have been I'm talking about the general HTC community has been part of ACCESS and the predecessors of ACCESS for a long time. But what's different this time is that we have a little bit of an insider track this time. And that happened as part of NSF breaking up how they awarded the ACCESS program compared to the Exceed and the predecessors. And the ACCESS project was broken up into different tracks. They competed the operations track separately from the allocation track, separately from the metrics track, separately from the support track. And my team ended up being part of the awarded support track. So that's the pyramid that we have here. That's from our proposal. It doesn't really, mean much in general, but really what it is it illustrates how we suggested that support should happen in ACCESS going forward. And the idea is that it's really, support more users with less resources. So the bottom of this pyramid has a couple of tools. So there's Open on Demand, and I'll get to Open on Demand in a second, and Pegasus. And the idea here is that we should have these tools available to users. They should be able to self-service at this level. So that's the base of the pyramid, the masses should be able to self-service and not have to go to support for everything that they want to do. They should be able to get started, should be able to go do their basic stuff without interaction of support. And that's why these tools are important in this forum. The cornerstone offering that we have is what we call ACCESS Pegasus. And this is an access point. It's a resource agnostic access point. So there's no resources attached to this one. It's based on the stack I just talked about, Open on Demand, which is a web interface to an HPC resource. Like if you run your own cluster, you can put Open on Demand in front of that, and it will do things like data management. It will do simple job submits. It will do you can run applications like Jupyter Hub, which is what we're going to talk about here. But a really important aspect of Open on Demand and why it works really well in this case is the CI logon and the ACCESS IDP integration. So any user that has an ACCESS account can authenticate and log into this resource, just don't do anything. We don't have to do account setup, no nothing. And that has really made this a kind of low barrier of entry system. When you log in, you will see a couple of applications. There's only a few. We have a local shell, and we have a Jupyter Notebook app. That Jupyter Notebook app is then what you use to manage your workflow. Like we will use it to describe your workflow, use it to submit your workflow, and manage your workflow going on. Under the covers here, well, standard HTCondor access point, right? We have our SCAD, and it's also central manager so that glideins and other things can register into it a little bit later. But this is, again, our main offering. And we're going to talk about how to get resources in here in a second. But before I do that, I'm going to talk about the two other access points that we have floating around. And actually, before that, I'm going to just have a extra slide here. This slide I added because we had some hallway discussions about Jupyter hubs and where they're running and what they're doing. And I think this is important because the Jupyter hub I'm talking about here, which is a very similar deployment to what we do in the OS pool, it's running on the access point, all right? And so we use these Jupyter hubs to orchestrate our workloads. They're not really doing the computation. They are there to submit the work. They are there to, maybe do pre-processing and a little bit, visualization afterwards or something like that. But that Jupyter Notebook is not the one that actually runs as a job, right? And that's opposed to some of our users that come in and they have a Jupyter Notebook with, let's say, PyTorch or something like that, and they want to execute that notebook as the actual computation. And in that case, we have to schedule the notebook on an actual execution point. And I just want to be clear that that's not what I'm talking about here. So the other couple of access points we have, one is sitting at the Pittsburgh Supercomputer Center. The driver for this deployment was that they have a very special AI machine called the Neocortex. If you have nothing to do tonight and you want to read about some cool hardware, Neocortex is something to look up. It's one of these really big wafer machines that are very AI optimized, right? And why they used a baseball for size comparison, I don't know. Maybe they were out of bananas or something. But it's a really big wafer compared to what we used to in CPUs and GPUs. And what PC wanted to do was to run workflows that had some parts of AI jobs and some parts general purpose jobs, right? And they wanted to be able to split those jobs. Like the AI jobs would go to Neocortex, their general AI, the non-AI jobs would go to their general computing cluster like the Bridges 2. And the front end to this AP is almost the same. There's an open on demand that the PSC already had. It schedules a notebook onto an HTCondor AP. The third AP that we have deployed support is in the Purdue Anvil Composable Subsystem. So Purdue Anvil, it's mostly a traditional HPC cluster. It has Slurm, it has a bunch of compute nodes. But then there's a partition that's attached to it that is the composable part, which is really a Kubernetes cluster that shares or connected well to file systems and user authentication and so on this machine. And what's neat about this is that you can start, in this case, JupyterLab instances that gets mapped, UID mapped, group mapped to the same user as you have on the cluster. You will see all the parallel file systems on there. It's configured so to allow Slurm jobs, so you can interact with the cluster, but you get your own little submit node doing so. And what we have done is we work with Purdue to just layer, take their container image. We added Condor, we added Pegasus, and you end up with like a dynamic AP that you can just start whenever you need it and interact with it. And this is a JupyterLab instance, so there's a little bit more powerful than our Jupyter notebooks. But more importantly, what's really unique about this one is the co-location of Condor and Slurm here. We can easily translate jobs from Condor to Slurm on the same machine. And it really enables things like parallel jobs and quick interaction with the file system. So it's a very nice environment that they provide here. So far we talked about the APs. So now the question is, of all the resources that are available on ACCESS and NAIRR, how do we get access to them? How do we run jobs on these resources? And the short answer is glideins. Almost everything we do here is glideins. If you forget about what I just said about Purdue and co-locating that, pretty much everything else is glideins. And what's unique about this is, and what's different from, for example, the OS pool, right, is that these are allocatable resources. So the glideins, a real key part here is that we want the glideins to start and run as the user themselves under their allocation. We want them to charge to their own allocations, right? And so that who starts it, how it gets started is really important here. The list here is just some of the ACCESS resources, and there are more of them, and there are an overlap with the NAIRR in some cases, and there are some additional NAIRR resources. So this is not supposed to be complete in any way. But the point I'm trying to make is that there's a lot of diverse resources here. So we think about ACCESS and that may be mostly HPC systems, but there's more and more. They call it novel computing, but that's not really what it is. It's just different systems. So we have systems like Voyager, which is at SDSC. That's a Kubernetes cluster. And we have the OS pool is in here. We have the path facilities on NAIRR. And we have cloud resources like Jetstream 2. And the point here is that there's not like one glidein that fits all these resources. We need different ways of starting the glideins, targeting the different types of resources that we want to go to. And this figure here is just a little bit of an overview of the different ways that users can get those glideins started. And I'll have slides on at least some of them in here, so we're not going to spend too much time on the figure. But there's a bunch of different ways of doing this.
Yeah, I would like to comment here, and I know that I'm preaching to the choir, that there are definitely technical differences, but the main obstacle is the allocation accounting approach of the ACCESS infrastructure that we are trying to change, because it's just an accounting challenge rather than a tech. I mean, you're addressing all the technical challenges, and whether you call it a backpack or whatever it is to get the application to run in this environment. And it's unfortunate if there's anyone listening online to influence ACCESS is to address the accounting thing, because it's just a self-inflict a punishment on the community that would like to use Pegasus to manage its workflow.
Yeah, and it's not only Pegasus, right? As I said, we have interacted with this communities for a long time, and it's that we've had that discussion for a long time. So this is really the way we can work within that framework, and it's not because we like it, but that's how it is. Most of our new users end up using the TestPool. And this is a small number of resources that we have attached to ACCESS Pegasus. And these are not charged to the user's allocation. So we have a special allocation. This is really more akin to the Science Gateway kind of way, where you can run small things without getting charged for it. And then if you have something bigger, you would graduate and you would get your own allocation. But something that's really interesting about the TestPool is that it allows us to do things like tutorials and classroom work and testing, debugging without having users to jump through all these hoops of allocation and provisioning and all that stuff. And it's been a really useful tool for us. We can go into basically any room, do a tutorial without users having to bring anything except an ACCESS account. And this is always available. As I said, it's not big, but it's really useful. This together with a bunch of test or sample workflows that we installed in everybody's home directory, that is a really game changer when it comes to demoing tutorials and using this in classroom. If you want to use cloud resources, I'm saying resources, but it's really Jetstream 2, which is the big one that we use. We provide a virtual machine image that acts like a glidein. So you start this VM under your own allocation. The only kind of input to it is a token and a username, and the virtual machine will start up, connect back to ACCESS Pegasus, and when there's no more work, it will automatically shut down. So it acts just like a glidein, but it's a VM. Where this has been really useful is, for example, long-running jobs, right? Because it's a cloud resource, people can run, training and long-running jobs like that for weeks, and they don't have to worry about, what is the queue length or queue maximum time in this HPC resource. So, and there's also a lot of different resources. You can obviously scale these based on, how much memory, how much disk, and things like that you need. So it's a very flexible resource if you have special resource requirements. For the HPC systems, we use mostly HTCondor Annex. This is Todd Miller and team that created this tool and provides it to us. And this is a glidein provisioner over SSH. What's neat about Annex is that it knows a lot, like it already pre-configured for a large set of resources. It knows about queues, it knows about the resource, it knows where to put stuff. So as a user, you don't have to kind of go there and figure out the resource. You can just use this little command line. There's an example at the bottom where you tell HTCondor Annex create, you ask it how many nodes, how much lifetime, what project to charge to, and queue and resource, and it will provision for you. It already knows a lot about the large number of the ACCESS resources and some of the NAIRR resources. So this is our really go-to tool. If all else fails, we have a little script that we call Pegasus glidein, and it's really just a wrapper around Condor, write some config, and then starts up. And the reason we have this tool is it's not even widely kind of announced, but it's kind of a thing that we have in our toolbox when users come and ask about, what about my lab machine, or what about my campus cluster that's behind a firewall and all this stuff. And we can bring out this tool, and they can use this to get glideins on those resources as well. So this is the Swiss Army knife of glideins that we use as a backfill. So far, I mean, I've talked mostly about our building capabilities and access points and so on. But a huge part of this project is really outreach and workshops. We, one way to think about this is that, we have spent a couple of years now building this. Now we're focusing on reaching out to people. We do workshops. Like a couple of months ago, we did the NAIRR AI Unlocked workshop, which was very, very successful. We did a big tutorial there. There's going to be regional versions of this, traveling circus at a couple of places. There are not many dates announced, but there's one at RMAC, and then the other ones are still undetermined. We go to PERC, we go to USRC, we do tutorials on Zoom. And just one little anecdote is when we were at the NAIRR AI Unlocked workshop, we had a student that came up to us and said that he was doing a Pegasus tutorial in a week, and a week after the NAIRR AI Unlocked. And that was the first time we heard about this. So we asked him, what can we do? What can we provide for you? Is there any material or anything that you need? And he said no, because the way that ACCESS Pegasus is set up with just requiring ACCESS accounts, the fact that it has the TestPool, and the fact that there are little sample workflows, said I have everything I need, and I can go and do this workshop for you without doing anything special. So again, I mean, it sounds minor, but I think it's been very, very helpful for us, and we're going to keep on building on top of that. So With that, that's everything I had. Thank you much.
Matt, do you have a short list of what we can do different, better, what have you, from the perspective of Pegasus representing the researchers that are coming via Pegasus?
Yeah, so I mean, we have obviously a continuing engagement with your team. I think keep on going with Annex. I mean, that is the one that users see here. Other than that, I think we are pretty good shape. There's always development in Pegasus happening, but as I said, now the focus should be the outreach. It should be talking to people here about making more example workflows. We'll talk to Brandy, for example. Hopefully, we can make something of that, and just keep on pushing, because like the technical aspect of this is in a very good shape. And it's also, the cycle that we're in. We just finished third year, and now we have to start showing some uses of it. So, and I appreciate actually Todd and his team, like everybody's help getting the Annex set up and all that. So thank you very much for that.
Yeah, I just want to make sure that if there is a short list, we are all aware of it, or the community here has an opportunity to say, yes, we suffer from the same thing, or
Right.
we are wishing or praying for the same thing.
Right. Thank you.
There's no more questions, so thanks, Mats, again.